start the lecture on nanotechnology in chemical engineering. So, today we will discuss about application of nanomaterials. So, that is for wastewater treatment. So, already we have discussed about the synthesis of various type of nanomaterials, how we can prepare various type of nanomaterials. That nanomaterials may be metal based materials, metal oxide materials, carbon based nanomaterials. So, various type of nanomaterials we have discussed synthesis, and then we have discussed the characterizations of the nanomaterials, how we can characterize. Now, we will discuss more details about the applications of the nanomaterials, nanoparticles that we have prepared. So, from chemical engineering point of view, so the nanomaterials, that is basically metal or metal oxide, carbon nanotubes, CNT, or carbon, porous carbons, activated carbons. So, many materials are there. So, that can be used from for wastewater treatments, mass transfer applications, particularly from the flue gas CO2 absorptions or CO2 gas separations. So, there's nanomaterials play extremely vital roles for the separations, increase the efficiency or performance for the conventional process or method. Also heat transfer operations, so that is also important chemical engineering process. So, there also we can use nanomaterials, so in the form of nano fluid preparation. So, that we will discuss. Also the nanomaterials having, whether it is metals, metal oxides, or composite, or maybe supported, so whatever. So, that materials having catalytic properties, so various reactions it can be used. So, in the form of catalyst, photocatalytic reactions it can be used. Also for biofuel productions, that is also another applications where nanomaterials can be used for the productions of hydrogen or hydrogen rich gas or methane productions. So, ethanol productions, many applications are there, biofuel productions, that we will discuss. Also the nanomaterials for enhanced oil recovery, that also can be used, means oil extractions or recovery from the ores where it is available. So, from there nanomaterials play a diverse role, so various roles to improve the performance or operations efficiency. So, that we will discuss. Also hydrogen energy, that is in terms of hydrogen storage or productions, that also we will discuss where nanomaterials can be used. So, today we will basically discuss the first one, that is the wastewater treatment. So, in wastewater treatments, that nanomaterials play vital roles. Here initially in content for wastewater treatments, first we will discuss various sources of wastewater. So, in wastewaters, conventional or traditional water purification methods are there, that we will discuss, and after that nanotechnology and nanomaterials that would be apply for the wastewater treatment. So, in wastewater, nanotechnology means by adjacent technology and membrane technology. So, nanomaterials can absorb that pollutants or metals, ions, metals, that is presents, pathogens presents in wastewater, that can be separated out from the wastewater to make it purified good waters, purable drinking water. So, for that adjacent technology is there. Through that various metals can be, metals in the form of metal ions can be separated out. So, that we will discuss, and then membrane based technology is there. So, where nanomaterials incorporated as a filler inside of the membranes, polymeric membranes. So, in membrane technology, where through that force waters may permit or that may pass through that. So, with that also small ions or other components may pass through that. So, if we use nanomaterials, so we can get better performance of the wastewater treatment process. So, that we will discuss. So, here so already I have discussed that there are various type of nanomaterials, that may be metals, metal oxides, zero valent metals, TiO2, CNT. So, these are the most commonly and cheapest materials that can be synthesized many process, and that can be used for the wastewater treatments. So, membranes also, nanofiltered or hollow fiber membranes, nanoparticles based membranes, or CNT based membranes. So, that can be discussed in our next slides. So, here the pollutants basically that is present in wastewater, that may be different type of metal ions, that may be arsenic, cadmium, chromium, silver, selenium. So, these are the metals ions that presents in different oxidation state. So, that is bad for health or human health, plants, other things, through that it is contaminated the water and that is transferred to the plant and living elements or life of that is polluted waters, that fish or other components are present. So through that we are coming or we are consuming that, or that is coming to the human's body, and therefore many health issue that is observed due to those pollutants, metals, ions present in wastewater. Therefore if we want to take pure and good drinking water, so then see, with the help of nanotechnology we have to separate those ions to get a good treated water. Also dye based pollutants, that is also may be present in wastewater, that also we have to separate it out, and we can separate that by adsorption base or maybe decompose that materials with the help of nanomaterials that acts as a catalyst. Also biological or pesticides based pollutions, so virus, bacteria, that is also may be present in wastewater, so we can separate it out. So application of nanotechnology, so different metals, oxide, nanomaterials, membrane based, these are the two way we can treat the wastewater. So here's just conventional, so wastewater, so raw water to pure waters we can get through this various process. So microfiltrations, ultrafiltrations, nanofiltrations, reverse osmosis. So here you can see in this nanofiltration, so in this particular place here different type of metals ions are present. So in this filtrations process, if we means modify these filtrations with the help of nanomaterials, so then these are the ions we can separate it out. So now if we talk about waters, wastewaters, so then in the totals earth, the water that is present 78%, 70% of earth surface is covered with water. So out of that 70% water, saline waters is content 97.5%, and out of that 70%, so fresh water content very less amount, that is 2.5 percent is fresh water that is available, and out of that fresh water, so mostly 68.9% is ice, glacier, slow, that way it is present, and rest is 30.8%. Out of this fresh waters is groundwaters, and from that groundwater easily accessible for humans use, so that is very less amount, 0.3 percentage. So therefore to get a clean safe water for the basic asset for a flourishing society as well as thriving of economy. So since due to the rapid increasing the populations and expanding the industrializations, urbanizations and extensive agricultural practice, so that causes actually contaminations or water quality gradually deteriorated, so day by day. So therefore we need to get means good water for our use. So we have to means the demands of drinking water, so day by day gradually clean drinking water increasing. So therefore I think so there are, these are the different pollutants that is the present in that water, so that we have to separate out, and these pollutants we can classify also in terms of organic, inorganic or biological water pollutants. So now already we have discussed, so how that is coming, these pollutants means from water to living systems in waters that is coming, and then from there to the surface means plants that is transferred, and from there to the human's body that is coming means through consumptions of fish or shellfish from the sea waters we are getting, or seafoods that we are consuming. Through that actually those heavy metals, metal science, pathogens that is coming to humans body. So therefore that causes many kinds of disease, so diarrhea, trachoma, so different type of means disease may appears, or maybe we can see with due to these contaminations or means metal science or other components present in waters. Okay, so therefore so we have to take the help of nanotechnology. So with that help, so we can get that and treat that waters into a fresh waters. Okay, so here's these waters various sources of wastewater, so already have discussed. So that's due to the industrializations, that from that industrial effluents that is coming out that disposed to the environment, through that so many metals, metal science and dye component contaminated the water, so therefore the water is polluted. Okay, so domestic hospitals sewage also, that is another source for, that is for wastewater. Industry is there, agricultural waste also there. So in wastewater mainly if you look into that, so the sewage water or wastewater, it is contains 99.09 percentage waters and solid ratio is 0.1%. So out of that organic 70% and inorganic materials that is present in that solid that is present in wastewater is 30%. So in out of that inorganic sediment, salts, metals that are present. So those quantities very small, but not small, very large quantity. And organic sediments, proteins, carbohydrate, fats, these are also present in wastewater. So here before go through the separations process, so we need to know about the water quality parameters, that is very important by Indian standard and WHO standard. So as per WHO standard, so water quality must be this type of permissables values for temperatures, pH, DO, BOD, COD, TDS, turbidity and different ions present, hardness, alkalinity, these are the WHO and standards. So as per WHO standards, so the good quality of water that is usable, and Indian standards also it is available here by considering pH, other component, temperature, turbidity and metal ions are present. So particularly calcium chloride, magnesium, these are present. So that is the Indian standard. So now the method of separations. So if we want to separate that different type of contaminants, that is in terms of metals, metal science or dye, pathogens, whatever it is present into wastewater. So if you want to separate, there are many methods, means traditional method of water purifications are the first one is the boilings. So if you do the boilings, if you do the filtrations, solar disinfections, so chemical disinfections, sedimentations, three pot methods or aerations methods, these are the traditional water purification method that can be used to purify the water. And then advanced technology has been comes, that is the microfiltration, ultrafiltrations, nanofiltrations, reverse osmosis, advanced oxidation process. So out of that, so these methods further modified with the help of nanotechnology. So where nanomaterials can be used for this treatment process, so that can enhance the performance and also water quality. So here I said there are two different method, adsorption technology, and by that way different type of metals, metal oxides we can use for the treatments of the wastewaters. That wastewaters will be purified through this process, means these metals or metal ions that we use for this process, and then wastewater will pass through this process through these nanomaterials, and then what are the metals, bivalents, monovalents, whatever the metal ions are present, that will be adsorbed over that surface of these nanomaterials, and then we can separate it out those materials from that wastewaters, and then by that way we can separate out. Another one is the membrane technology or membrane based, so where different type of nanomaterials, CNT, cellulose, graphenes, that can be incorporated in the membranes, and then that can be used for the separations of water or wastewater. By that way we can get good quality water. So first we will discuss about the adsorption technology. So how adsorption technology can be helped for some wastewater treatments. Okay. So here in adsorptions, actually there are different type of pollutants that is present, I said. So that pollutants basically adsorbs over the surface of these nanomaterials through the adsorptions, we can separate them out. So these pollutants adsorptions, that depends on various factors. Factors means temperatures, pressures, nature of adsorbate, nature of adsorbents, and pH, concentration of the pollutant, contact times, particle size. These are the various factors or parameters that would affect the adsorption process. Since in waters that metal ions may be bivalent, trivalent, monovalent ions are present, that would be adsorbed over the surface of that nanomaterials. That adsorptions may be weak or strong, that may be physical adsorptions or chemisorptions. So by that way, two way it may be adsorbs and adsorption process, and by that way we can separate out those metal contaminated from that process. Okay. So here various nanomaterials have been are used, and alumina, titanate, titanium dioxide, zinc oxides, and many other oxides, sulfides also can be used for wastewater treatments. Okay, so since these are these nanomaterials, why it is gives good or better results when we are using nanomaterials for the separations of the various metal ions, since it's having large surface area, easy separations, high reactivity, small size. Sometimes this small size good for that separations of those ions, and sometimes it has also adverse effect due to the small in size that we will discuss. Okay. So, now eliminations of metal based pollutants from the wastewaters, how we can use nanomaterials to separate out pollutants that is present in wastewater. So here first alumina that we discussed. So, alumina nanomaterials in the nanoforms metal oxide that we can use to remove various metals, and that is copper, cadmium, chromium, lead, mercury. These are the metals and we can remove with the help of alumina that can be used. Zero valence irons also can be used to separate out arsenic, cadmium, chromium, silver, selenium, lead, zincs. These are the metals if it is present in waters in the form ionic state. So, then with the help of zero valent ions we can separate them out. Similarly, titania also can be used. So, for to inactivate different type of pathogens that we said bacteria, virus present in water that can kill the titania. So, we can use these are the materials also. So, first if you want to separate arsenics, so arsenics that may be present in water, so that may be plus 3 oxidation states and plus 5 oxidation state, both the oxidation state are present. So, plus 3 is 60 times much more toxic than arsenic 5. So, arsenic if we want to separate it out, it has permitted limit. So, that is 10 microgram per liters as per WHO. So, if it is more than that, then there is many problems. So, that may comes on in the form of digit we can see. Okay. So, therefore, so these arsenics is we can separate it out by using nanomaterials. So, here coagulations, filtrations, membrane separation or ion exchange adsorption methods we can use. So, in ion exchange adsorption methods here that particularly we will discuss. So, here zero valence ions can be used. So, here you can see one table is given. So, here pollutants that is arsenics. So, that is plus 3 and plus 5 oxidation state. So, that pollutant present in wastewater that may be separated out by using different type of nanoparticles at adsorbents. So, here different zero valence ions, activated carbons that is given iron oxides, iron manganese oxides, that iron oxide, titanium oxides, zinc oxides. These are the various nanoparticles that can be used to separate it out, and specific pH also that is very important. So, that conditions is also given. So, removal capacity milligram per gram. So, that is given depending upon so that materials we are using the for separations of arsenic 3 or 5 that is present in wastewater. Okay. Similarly, some other metal oxides also nanoparticles that can be used for that separations of. So, for arsenic 5 or arsenic plus 3 oxidation state and different quantity. So, sometimes we can use titania TiO2. So, that is most suitable for removal of arsenic 3 or arsenic 5. So, next is the cadmium. So, here cadmium is also another metal science that is present in waste, or that also we can separate out. The permissible limits for intakes, human intakes is given as per this 60 microgram per day. So, 270 micrograms. So, if we want to separate that cadmium, so here's titanium dioxide nanoparticles modified with the thiol acetic acid or unattached nanoparticles of TiO2, silica aluminum nanoparticles. These are the nanoparticles we can use for the separations if cadmium ions are present in wastewater. So, these nanomaterials we can use that can be separated out, and here you can see different type of cadmium, means cadmium plus 2 oxidation state pollutants that is present in wastewaters. The through different type of nanoparticles as an adsorbents we can use, and removal capacity also depending upon that materials we are using, which is also given. So, less than 7, so less than 5, 6.18. So, depending upon that conditions it can be used to separate out. So, okay. Similarly, chromium is also another pollutants that also can be used to separate it out. Here chromium two different oxidation state chromium plus 3, chromium 6, two oxidation states are there. So, these are chromium 3 is insoluble in water, chromium 6 is quite soluble in water. So, we have to separate them out with the help of iron oxide based nanoparticles, that is better than iron oxide powder. So, we can use iron oxide powder or iron oxide nanoparticles. Iron nanoparticle is better to separate out this chromium pollutants. Okay, chromium 6 that is adsorbed in iron oxides, that water, groundwater that we have, there chromium 6 contaminations is there, that we can separate out by using iron oxides as in nanoparticles adsorbents. Okay. There are some other materials also, here it is given. So, different type of nanoparticles that can be used for separations of chromium either 6 or 3 oxidation state, and removal capacity, for examples here if we use iron manganese oxide nanoparticles 10 nanometers size, particle size, to separate chromium 6. So, here removal capacity is 31.5 milligram per grams. Okay. So, at pH 2 and at pH 7 irons if we use, so that also can be separated out. So, here this removal capacity is not given. So, similarly cobalt is also another toxic element. So, that is present in wastewater, that we can separate out by adsorption method by using different type of nanoparticles. So, that may be iron oxides, ferrous oxides we can use to remove the cobalt from the aqueous solutions. Okay. So, ferrous oxide with 10 nanometers particle size. So, we can separate out cobalt 2 ions or 0 valence ions we can use to separate the cobalt 2 ions, and removal capacity is 59.63 when 0 valence ions are using. Okay. Similarly, copper is also another pollutants that also we can use to separate out from the wastewater. So, in that case chitosions bound ferrous oxide nanoparticles that we can use to remove copper plus 2 ions. So, for that we have to use pH more than 2. Okay. Similarly, selenium is also there. So, another pollutants that also we can separate out from the wastewater. So, for that titanium oxide nanoparticles we can use for the selenium science. So, different type of metal science. So, we have discussed different type of nanoparticles we can use to separate out those nanomaterials. So, next is the organic based pollutants. So, different organic based pollution, that is the dye based pollution pollutants presents, pesticides based pollutants, hydrocarbon based pollutants, biological based pollutants, even various virus bacteria. These are the different organic based pollutants if it is present in wastewater. So, we can eliminate different type of nanoparticles we can use to remove those. So, let us say having this type of red 195 azode is present, that is for that to separate out titanium nanoparticles very effective. Similarly, MgO nanoparticles is very effective when azo and anthraquinones reactive dye is present in wastewaters, industrial wastewater, we can separate them out. So, here is a list of pollutants is showing. So, different type of dye that is present in wastewaters and different type of the nanoparticles. So, that we can see use titanium, MgO, ferrous oxide, chitosan, zinc oxide. So, we can use, and removal capacity is excellent, 87 when TiO2 is used for removals of this 87 milligram per gram removal capacity. Similarly, others also that is showing here. So, if pesticides based pollutions are present, then we can use silica nanokaolins particles that we can use, that can remove atrazines, that is one kind of pesticides pollutants that can be removed from that adsorption process. Okay. Hydrocarbon based also pollutants, that is phenanthrines, that if it is present, so that we can removed by using nano titanium, zinc oxide nanoparticles or nano alumina. We can use nano alumina coated with humic acids, we can use to separate out these hydrocarbon based pollutants if it is present in wastewaters. Okay. Similarly, there are different biological contaminations are present in wastewater, that also we can separate it out virus bacteria. So, using zero iron oxide nanoparticles we can use, nanoscale zero valence ions, that also we can use as bactericidals for E. coli contaminated groundwater. So, zero valence ions or ferric oxides we can use for removals of this type of means contaminations or virus bacteria present in wastewater, we can remove with the help of nanomaterials. Okay. Next is the membrane based technology. So, in this membrane based technology also, so polymeric membranes we can use for the filtrations of that wastewaters, and before For the preparation of the membranes, in membrane based technology, actually here nanoparticles we have to use different type of metal oxides that already have discussed. So that may be carbon nanotubes, graphenes, or maybe alumina oxide, iron oxides, nanoparticle, titanium oxide nanoparticles that we can prepare, and after that that would be embedded in the membranes. Membranes is polymeric materials, so that consist of different type of pores, so that nanoparticles also distributed in that membranes, and after that when wastewater would be passed through this process, so then this actually nanomaterials that is acts as a nanofillers. So when a different type of metals ions, that may be organic, inorganics, means components that is present in wastewater, that would become in contact with the nanoparticles and then would be adsorbs or contaminated reacted with that surface, and by that way we can separate them out. Okay. So here Ti2O2 base membranes, that means TiO2 nanoparticles that would be used for the modifications or fabrications of the membrane. So once it is fabricated, and then this can be used for separations of contaminations that is present in wastewater, that may be organic or inorganic substance that is present in wastewater, that can be removed easily. Similarly, silicon dioxide nanoparticles that is incorporated in the membranes, so that can increase the water flux and anti-fouling properties of Ca polymeric membranes that used for the wastewater treatments. So silver based nanoparticles that also can be used in the membranes based technologies. They are silver nanoparticles embedded with ultra fine membranes, so that is silver polysulfones nanocomposite we can mix, and that can use for that antibacterial properties, so that can be used for the wastewater treatment. So here's low concentrations silver nanoparticles, that is very essential, and that is having antibacterial effect, so that we can use for that treatments of wastewater. Similarly, zinc oxide based nano materials we can particles we can use for the membrane fabrications modifications, and then that can be used for separations of different type of components presence in wastewater. Similarly, carbon nanotube based, that is graphene single walls multi-wall carbon nanotubes, that also can be used. Membrane based technology means here CNT is better than activated carbons, so means we can use activated carbons or carbon nanotubes. So it has been observed that, so if these are the different metal ions are present, if you want to remove lead, silver, copper and cobalt ions, so then CNT is much more better than activated carbon. So we can go for CNT preparations, CNT materials, and that embedded with the membranes, and then that can be used for that separation of those metal ions contaminated in wastewater. Okay, so different type of nanomaterial, that is multi-wall carbon nanotubes, that is in combines with activated carbons, or multi-wall carbon nanotubes with iron oxides, that composite we can use as an adsorbent, so that can remove this type of metals and means strontium or arsenics, nickels, contaminations in water, and removal capacity is very good, and that pH also, that is important parameter for this for separations. Okay, so even I said that nanomaterials can be used for catalysis purpose, photocatalysis. So CNT, zinc oxide, titanium oxides, this can be used for photocatalytic activity to degrade the contaminants that is present in wastewater, so that we can separate out. Okay. So here's different methyl orange dye, rhodamine B dye, Kango red dye. So that can be used different type of functional nanomaterials, and here photocatalytically we can remove these organic contaminants. Okay. So here's other materials is also there, so that also we can use. And I said nanomaterials having very high surface area, surface to volume ratio. So it has surface area extremely good, so that is for therefore that materials can be used for that wastewater treatments. However, due to the small size of the nanoparticles make them easy accessed into the living organisms. Therefore, nanoparticles when comes into the body of humans, so then that causes DNA mutations. Nanotoxicology means that comes to the human's body, the nanoparticles that is we are using for wastewater treatment by adjustments of membrane technology. Sometimes that particles size is very small, therefore that may come and may cause different type of toxic features in our human body. So therefore, that is the present in means disadvantage using nanomaterials for wastewater treatments. Okay. So therefore, conventional way of preparations of the nanomaterials, instead of that, so synthesis of greens nanoparticles from bio-waste products, that could be alternative way to reduce the toxicity and utilizations of the nanomaterials for the wastewater treatments. So by that way, you can slightly reduce the toxicity of that nanomaterials that is being come to the human's body and that affect the humans. So another is the nanotechnology membrane based distillation. So here's membrane based distillations. I think here's feed waters or waste waters we can feed here, and this is the membranes. So here's through that, this is through this tube wastewater we can pass, and then quantum fresh waters as a permits that can come out these sides through that membranes are in ports, and through that what fresh waters we can get here and contaminated or waste waters that may pass through this. So here's membranes we can modify with that different type of materials I said. So graphenes, zinc oxide, CNT, different metal oxides we can use and modify that materials, that membranes. So therefore that can helps to separate out the different type of contaminants that is present in wastewater. So easily we can separate out. Okay. So here's once graph is showing, so permeate flux with the times and using cellulose acetates in the membranes. So then the performance is that, so when 1% or 2% titanium nanoparticles if you use with the cellulose acetate and prepare that membrane, so then that is much more effective. Okay, so like that different type of TiO2, SiO2, that nanoparticles that we can use with that polyamide polysulfones, that is the composite membranes. So that we can mix and that can use or blends with CNT also. So that is much more effective for the different type of separations process or wastewater treatment. So here also you can see graphene oxide and multi-wall carbon nanotubes, that is very effective. So here PVDF that was used, polyvinylidene fluorides. So that membranes was used with that graphene oxide or CNT, multi-wall CNT was used. So here's the reactions capacity gradually increase if we use either graphene oxide or multi-wall CNT. So initially PVDF, so it has a rejections capacity that was 60.7.6, and so when graphene oxide is used it is increased rejections capacity of pollutants, and then if we use multi-wall carbon nanotube with the PVDFs, so polyvinylidene fluorides membranes, so then the rejections capacity of the contaminations that gradually increase. So here's different depending upon that materials. So we can prepare different type of membranes and we can remove the contaminants that is present in wastewater. Okay, so therefore I think the nanomaterials, whatever the materials in carbon nanotubes, that is graphene, graphene oxide, titanium dioxide, iron oxide, that whatever the materials we are preparing, silicon dioxide, alumina, or other nanomaterials or nanoforms of materials that directly we can use by for the treatments of wastewater by adjacent methods or by membrane technology. Both the way we can separate out many pathogens or contaminants that is present wastewater to treat that water to get. So that is the application, one applications of nanomaterials for wastewater treatment. So that we have studied. So thank you. So today is up to this. Thank you.